Alright, maybe part two, maybe just the same video. Who knows? It's all mystery. Anyway, so we are continuing. We learned about energy roles, carnivore, omnivore, herbivore. Now we're talking about competition and predation. I think both of these are pretty obvious as well. So two major types of interactions exist among organisms, competition and predation. So you guys compete in almost everything you do in life. You compete for chairs in the cafeteria. You compete for top of the class or valedictorian. Maybe you're competing for a prize in my class with the prize wheel. You're competing for blue tickets. You're competing for a top locker. I know y'all did that at the beginning of the school year. So competition's out there. And then predation is predator-prey. So these two lemurs, ring-tailed lemurs, most likely what they're doing is just competing for something. Maybe a mate, maybe some food, maybe dominance. Maybe they're just doing a weird dance. I mean, I'm not a lemur. I don't know. So different species can share the same habitat and food requirements. Oh goodness, I need to retire. Requirements. So that could pose a problem. I mean, think about moving. You might move into a different apartment or a different house, you and your family, and you might say, hey, I'll give you $1,000 a month if I can live here. And someone else might come in and say, hey, I'll give you $1,100 a month. That's competition. And obviously the landlord is going to take whatever one offers more money or meets their requirements better. So if two species occupy the same niche, we're going to talk about that word, that's why it's underlined, same thing with habitat, we're going to talk about more later. One may eventually die off. So we have some good examples here, but this is all due to competition. So when two animals want to live in the same place, kind of in this unit, what you're going to see is animals have two options in nature and plants. You can adapt or die, and unfortunately that's kind of the way it is. If an animal really likes the tree that has, let's say, the lemons on it because they're really into lemon, and there's another bird that really wants to live there too, they can either adapt and go live somewhere else, or they can just sit very sad off to the side and just kind of want that tree from afar. So animals in nature, they're going to adapt so that there's less competition. So competition, of course, there has to be a big fancy definition. It's the struggle between organisms to survive as they attempt to use the same limited resources. So not too big of a definition, and I don't think it's too hard of a definition, because like I said, you all compete almost every day. So there's only, let's say 30. Let's make up a number. There's only 30 seats in the cafeteria, okay? And there's always a really good seat. Some of you kids like to sit on the ends, and some of you like to sit smack dab in the middle. And that's competition. If someone, let's say I always sit on the end seat, the one closest to the vending machines. That's my seat. And Miss Sewell comes in and she goes, Miss Riddle, I'm going to sit there today. And I'm going to be like, no, you ain't. No, you're not doing that. And I start snapping my fingers all sassy like. That's competition right there, okay? We are competing for the same limited resource. So you kind of already know this definition. To be in high school, to be valedictorian is a really dream and goal for some people. That means you're the smartest person in all of 12th grade. That's a huge honor. And some people work their whole entire lives to earn that. They study and they work hard and they never miss school and this, that, and the other. That is a limited resource. There's only one valedictorian. There's no way someone else is going to come up and tie them, or it's very unlikely. So there's only one top spot, and there's a competition in order to earn that top spot. So there are often adaptations to reduce this competition, like I said, and we've been talking about adaptations now since before winter break, since the evolution unit. So we should know what an adaptation is by now. So maybe they're going to feed at different times of the day. One's going to eat at night and one's going to eat during the day. So I kind of clicked ahead, but on the next slide, I'll show you. So these are warblers. These are just birds, but they're all kind of related birds. So here's a conifer, or a gymnosperm, or a vascular seed plant. There you go, throwing back some old words. So this is your pine tree, basically, okay? You can see that each of these warblers lives in a different area of the tree. The Cape May warbler takes the very top outside area. See this dark green region right here? The Cape May warbler only lives right here. Now we look at this guy, the black-throated green warbler. Personally, I don't see any green on that bird, but that's a story for another day. So the black-throated green warbler lives only in this kind of upper middle area and towards the center of the tree. So notice that these two are very close, but there's a strip right here that separates them, so they don't have competition. Now we're looking down here at the myrtle warbler. The myrtle warbler, goodness, has this whole area, all of the bottom and the middle. It's all up in there. The black bay-breasted warbler, kind of a similar middle of the tree, and the black burrian warbler gets this outside. So all of them take a different area. They don't actually go into each other's habitats or areas of the tree at all. They stay very separate so that they don't have to compete. Because notice in their mouths, they all have a very similar looking worm thing. So they probably eat the same food. So at least now they don't have to share the same home. So interactions where one consumer kills and eats another one is called predation. So think of predator-prey. You've heard of these words before. I know we've used these words before, and I'm sure you heard them in back in 4th or 5th grade, whatever grade it was, way back in the day. So predator is the one that eats. Prey is the one that is eaten. So typically in life, you are a predator. You might go out and hunt. I know we have a ton of kiddos that go out and hunt. That's perfect. You're a predator. You go out, you shoot the deer, you might bow and arrow a deer, whatever you call that. You take it home, you skin it, you gut it, you eat it. You're a predator. Okay? So the one that kills is the predator. The one that is killed is the prey. Oh, right there is little Bambi. Poor little thing. One is looking at her thinking, I'm going to eat you. Blech. So predation can affect population size. So white-tailed deer are hunted for more than one reason. One is obviously for food, but a lot of times deer are overpopulated just because they like to kiss and make a lot of babies. I don't know. Sure, sounds good. So without hunters going out and hunting these animals, we would actually have too many deer. We would have more deer killed on the side of the road because they got hit by a car, and we would have all kinds of problems in the ecosystem because of this. So hunters actually play a real key, vital role in the ecosystem. So here's where, excuse me, here's where the issue comes in. If there are more deaths than births, the population size will go down. So think of it this way. If there are 100 deer in Virginia, which is a total lie, I'm making this up. There's 100 deer in Virginia, and it's hunting season, and 25 people go out and kill a deer. So 100 minus 25 is 75. So we have 75 deer left. But the mommies, the ones that are still alive, 20 of them have a baby. So 75 plus 20 puts us back up to 95. That's what it's saying right here, though. If more animals are dying than are being born, the whole population decreases. So if 25 get shot and 20 new babies are born, we have a -5 deer population. We've lost 5 deer. Okay, so that's what happens if there's too many predators. So you can see here, these, 6 lionesses, maybe even 7 down here, are all hunting this one bison, or one buffalo. Not a bison, buffalo. So that's probably fine. Those 6 or 7 are going to eat that one and be fine for a couple weeks or a couple days at least. If there was more, then a couple of them would go hungry. Sorry, I had to cough. So if they kill almost all of the prey, the predator population is going to die off. So this is where it gets a little tricky and a little abstract to think about. Let's use foxes and rabbits because it's pretty easy. So let's see what's going on here. Okay. Oh, that's a hungry lion. Okay. On the maybe next. There it is. Okay. So I'm going to describe it, and then I'm going to show you a picture on the next slide that's going to help reinforce stuff. So we have 10 rabbits, and each fox needs to eat 2 rabbits in order to survive. I know we're doing a little bit of math here, don't hate me. So if there's 10 rabbits, and each fox needs to eat 2, that means we can support 5 foxes, because they each eat 2. Perfect. Now, let's say that somehow we have 6 foxes that need to eat. Uh-oh, not a good thing. It means one of the foxes is going to go hungry. All the rabbits are going to be killed. So it needs to be a perfect balance, the number of prey and the number of predators. I'll show you this better on the next slide. So if your head's spinning, I understand. I think I need this next picture to show you. So here's what we're going to see on the next slide, though. Generally, the population of predator and prey are going to rise and fall together. So, like I said, it has to be a balance. They only give out so many, I think this is right, they only give out so many deer tags every year because they don't want everyone with a gun to go shoot a deer or bow and arrow a deer. They only want a certain number. They go out and they take survey and they say, hey, we have a 200 extra deer this year. We can let 200 people go out and hunt. So that's how it works. If they gave away too many, then the deer population would go down and next year we wouldn't be able to hunt. So, excuse me, goodness. So let's look at this graph. We have predator-prey interaction. Down here we have generation. Over there we have number of organisms. So we have rabbits and wolves. So we're seeing here, we're starting at 100 of each. As this rabbit population comes up, way up into 160, notice that the wolves come up as well. Because what happens is more food equals more predators. All those mommies are popping out babies, and life is happy. Then what happens is all of these wolves have now eaten all of the food. They've eaten all of the prey, all of those rabbits. So now the rabbit population tanks and it comes down just to 60. Nova, will you keep it down? So now all the rabbits, most of the rabbits are dead because they've been eaten. Well, guess what happens to those wolves? It comes down, 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 down. Because now they're going hungry. There's not enough food to support these. Well, now there's not a whole lot of predators. So now the rabbits that are alive, they just make babies. Because that's what rabbits like to do. They make a whole bunch of babies. So now there's a bunch of babies. Well, guess what happens to the wolves? The surviving wolves, they go, hey, there's more food. That means we know more babies. So it goes up and down together. And you're going to do a graph tomorrow that kind of shows this as well. So they're going to rise and fall together. I'm sorry, I'm coughing like crazy right now. So predators need to have adaptations to catch prey. These are pretty easy. Cheetahs are very fast, like this one right here. Cheetahs run very fast in order to catch whatever they're trying to catch. The antelope, the deer, I forget what those little guys are called. There's another little guy, I can't remember. Owls and bats have really good eyes to hunt at night. Claws, big sharp teeth, really good smell. All of those are predator adaptations. They need to be able to hunt their prey. But right along with that, the prey need to be able to have adaptations as well. They need to be defensive. Okay, so when you're being hunted, you need to always be watching your back. So a skunk may spray its stinky skunk spray. Whereas the sharp quills of a porcupine, they might, you want to see that again. Okay, the quills of a porcupine allow it to be protected. So, warning colors are used a lot of times. This toad, or this frog, excuse me, is bright blue. And what that says is, hey, I'm poisonous. You totally should not eat me. I taste disgusting. I'm going to kill you. No good. Sorry, guys. I got to move quick. Time myself out again. Another one might be camouflage, to help hide or blend in with your surroundings. So I have some pictures here. I'm going to throw them up onto Google Classroom. I want you to try and find those animals. I think it's pretty cool to see. I think I have one more slide, though. Another one is mimicry. So these two snakes, this one over here is venomous. This one is not. So it kind of just said, hey, I look like that other guy. I wouldn't risk it if I was you. I might be venomous. Oh, I made it. 10 seconds to spare. Go to Google Classroom, check the front board, make sure you know what you need to do next.